I am Anil Kumar. Welcome to my series on algebra. We'll begin with working with formulas in this particular video. Here are the formulas with which we are going to work. We'll actually reorganize. If let us say we take this formula y equals to 3 times x plus 5, then we'll rearrange to find the value of y. Sometimes we say isolate the variable. So that is the exercise which we are going to do. Once we do this exercise, we'll take related word problems. Now in this list, I'm going to solve all of them. However, I find that these are kind of level 2 problems. If c is equals to a minus b over a plus b, you need to isolate b. And this particular question also is quite difficult. Some of you might find this portion challenging just from the way it looks, but it is not all that difficult. What I would like you to do is pause the video here, isolate the variable written after comma, right? Rearrange and isolate that variable, and then look into my suggestions. Let me share with you the other problems which I am going to discuss. So we have some word problems here. As you can see, question number 5, question number 6, question number 7. So these 3 questions are the word problems related to reorganizing a given formula and then working with it. So that is going to help you understand why we do so, right? Now let's begin with the solution or isolation of these variables. So question number 1 here is, make the indicated variable as the subject of the formula. Now this language is used in many times, so therefore may not be familiar for people in North America, but for United Kingdom that makes a lot of sense. So make the indicated variable as the subject of the formula. That really means that you have to isolate p or to rearrange the formula and get the value of p for the formula given here, right? So let's do it for all the 6 formulas given. First is v equals to IR. We need to isolate what R is. How will we do it? Well, we can divide both sides by I. So if I divide both sides by I, so IR divided by I will leave only R here. So we get R equals to V by I. So that is how in 2 steps we could isolate. Perfect. So I'll write here R is equal to V over I. That is how we are going to isolate. The next one here, we need to isolate p. What should we do? Well, we can bring that minus 3p to the left side. So 3p is equal to m to the right side. So we get 2n minus m. And now we can divide by 3. So we get 2 over 3n minus 1 over 3m. Perfect. So we have isolated. Next is very similar to what we just now did. Here we have a bracket. So first we'll have to divide by 3. So we get y over 3 equals to x plus 5. And now we can write what x is, which is y over 3 minus 5. We could write this x on the left side directly also, right? So we could write this as this. Taking 5 to the other side makes it minus 5. Does it make sense to you? Now this is similar to what we did with slight variation. Very popular y equals to mx plus b formula is being organized now. You need to find what x is. Well, we can bring 5 here. So we get y minus 5 equals to 2 over 3x. And so what x is? X will be equals to 3 over 2. So when you multiply, cross multiply, you flip it. So you get y minus 5 equals to x. So that is how you could write what x is equal to, right? So I hope it is making sense to you. So I'd like you to now pause the video and answer the other 2 questions. Now some of you may even like to write this formula as x equals to, open the bracket, you get 3 over 2y minus 3 over 2 times 5, or we may write this as 3 over 2y minus 15 over 2, right? So you could write in this fashion also. Perfect. Now let's take up the next formula. We need to isolate what P is. So first step is cross multiply, second take away Q and then divide by 2, right? So we can now say this is equal to, let me change the ink now. So if you cross multiply, you get 3n equals to 2p plus q, and then we get 3n minus q equals to 2p, or 3n minus q divided by 2 is equal to p, or you could write p as equal to half of 3n minus q, right? Or you may expand it like I did here and then rewrite the formula. Both are correct. In the case of square root, this is Pythagorean theorem, you need to isolate what a is. In that case, c square minus b square will be equal to a square. So square root of c square minus b square is what a is. Now in this particular formula, normally you use it for sides, so you don't write plus and minus. However, whenever you do square root, you should be writing plus and minus. So remember that part. So you could write a as equal to plus and minus square root of c square minus b square, right? So in general, you should consider both. Now in many situations, one of them, especially the negative one, may not be valid. So therefore, you normally drop it. Is that okay? But truly speaking, you should be putting both plus and minus. Now let's take the other variety of this same, which is we have these three formulas now. So make the indicated variable as the subject of the formula 2as equals to v square minus u square equals to u. Now we can bring this u square to the left, so it becomes u square, and on this side we have v square minus 2as. Now dividing, I should square rooting both sides, we get square root of v square minus 2as. And as I said, you have to write plus and minus when you square root. So let me rewrite this. U equals to plus minus square root of v square minus 2as. Perfect. Now that is the surface area formula we need to isolate for height h. So we'll say surface area divided by 2 pi r equals to height plus r. So what is height equals to? So height is equals to surface area divided by 2 pi r, take away r, right? The volume formula for a cube, 4 by 3 pi r cube is the volume. You have to find what r is. So we cross multiply 3v equals to 4 pi r cube. So we can now divide by 4 pi. So we have 3v divided by 4 pi equals to r cube. And now we can take the cube root. So we can write r equals to cube root of 3v divided by 4 pi. Does make sense to you? So that is how we can do these formula 3. Now these are slightly difficult as compared to what we saw in question number 1 and 2. Make the indicated variable as the subject of the formula. C equals to a minus b over a plus b. We need to isolate b. So in this case, the strategy is to cross multiply. Right, so when you cross multiply, you get c times a plus b equals to a minus b, right? Now you can open the bracket using the distributive property. So we get c times a plus c times b equals to a minus b. The term with b can be kept together and the other term can be taken on the other side. So we'll take cb and bring this b on this side, and here we get a minus ca, correct? Now we can take b common. So when you take b common, you get c plus 1 here, and on this side you could take a common or just keep it as such. So well, if I take a common, you get 1 minus c here. So what is b equals to? So b is equal to a times 1 minus c over c plus 1, or you could write as 1 plus c. Does make sense to you? So that is how we can rearrange this particular formula, right? So other way, if you see to it, We could write this as B over A equals to 1 minus C over 1 plus C, or something like this. So this is a very interesting formula. You will use this in many ways in times to come. You can look into my videos on componendo and dividendo. For related questions, and that is going to be very interesting. Now, let's look into the next example, which is t equals to 2 pi square root of L over G. We need to isolate L. So it is within the square root. So once we, do the operations on both the sides, we need to square, right? Okay, so first let's divide by 2 pi. So we get t over 2 pi equals to square root of L over G. And then we have to square. So we get t square, or let me write like this, t over 2 pi whole square equals to L over G. So when you square square root, you get L over G. Now since both L and G are positive, we don't really have to write their absolute value. They're always positive. Okay. Now L will be multiplied by G. So we can write G times t square over 2 pi square is 4 pi square, right? So that is the value of L, or you can write L is equals to t square G over 4 pi square. Correct? So that is how you're going to do it. Now let's look into this, where we are writing reciprocal of a number is sum of reciprocal of other two. This formula is widely used in lenses. How do we isolate V? So the method here is to remember that, to add fractions, we have to have a common denominator. So the common denominator here will be u times v. When you do that, you get v plus u in the numerator. To make it v, you have to multiply both numerator and denominator by v. So you get uv in the denominator. On this side, you have to multiply and divide by u. So you get u over uv, right? So you get to this step. Perfect. So once you get to this step, then it becomes slightly easier to isolate. Now we'll cross multiply and do as we did here, right? So we'll now cross multiply. So we get uv equals to f times v plus u. You need to isolate v. So we'll actually get uv, open this bracket, so fv plus fu. Bring fv to the left side, so you get uv minus fv equals to fu. Take v common, so you get u minus f equals to f times u. So now we can write v is equals to fu over u minus f. Is that clear to you? So that is how we are going to get it. So let me rewrite the answer on the top. So what we get here is that the velocity v will, that focal length, so v is going to be equal to product of f and u divided by difference of u and f, right? So that is the result. So I hope you understand and appreciate how we could do this. Now, let's take the last question on isolation of variables. So once again, we have similar formulas as you did. I would like you to actually pause the video. Take these two as your test questions, solve them, and then look into my suggestions. So take this as a test. Okay, here is my solution. We need to isolate b this time. So the strategy here is to work as we work with fractions, right? So we have 1 over a equals to the common denominator is b times c. To make this, we'll multiply this with c, so you get c here, and multiply this with b, so c minus b, correct? Now we will cross multiply, so we get bc over a equals to c minus b times a, right? So we'll do it in the next step. We need not write here, right? So we'll just cross multiply. So we'll take BC to this side and A to this side, right? So we get BC, and then, okay, let's open the brackets. We get CA minus BA. Now we need to isolate b, so this term will take to the left side. So we get bc plus, ba this is. So we'll bring this on the left side, so it becomes ba equals to ca. Taking b common, we get c plus a in the bracket, and here we have ca. So you can write b as equal to ca over c plus a, right? So that is how we are going to do it. So I hope the steps are absolutely clear. How do you do this? This is a quadratic equation which you have seen so many times in vertex form. Y equals to 5 times 2x minus 3 whole square plus 1. We need to isolate x, right? So first step, we could take away 1 from both the sides. So we get y minus 1 equals to 5 times 2x minus 3 whole square. Now divide by 5. So we get y minus 1 over 5 equals to 2x minus 3 whole square. And now we'll do square root. And we get y minus 1 over 5 square root equals to 2x minus 3. So here, whenever you do square root, you have to write plus and minus. This is key, else you'll get the wrong answer, right? Let's bring 3 on this side. So we get 3 plus minus square root of y minus 1 over 5. That is equals to 2x. So you can now write what x is. So we can write x is equal to, you have to divide all this by 2. So you get 3 plus minus square root of y minus 1 over 5 and everything divided by 2. Does make sense? So that is what you are going to get. Now we'll start the second section, in which we have word problems related to isolating variables or changing the subject of a formula. I would like you to go through the question. We are going to take a small break here, enjoy some Canadian wildlife, and then get back to the solutions of these questions. I hope you enjoyed the wilderness. We are really fortunate to have such a beautiful part of nature along with our lives. It is we who need to take out some time and enjoy it. So let's continue from where we left. We'll now take up some word problems related to organizing or reorganizing a formula. Question number 5. It is a very interesting question. In volleyball, an attack is any offensive hit of the ball, and a kill is an attack that results in an immediate point. The attack value P in volleyball is calculated using the formula P equals to K minus E over A, where K is the number of kills, E is the number of attack errors, and A is total number of attacks. Now we have three questions related with this particular formula where you may have to reorganize and figure out the values. Part A. Calculate attack value of Kristi. She has 7 kills. So we need to calculate the attack value, which is P, right? So we need to find what P is. She has 7 kills. So the value of K is 7. 3 errors. Errors are E, which are 3. And 25 attacks. A is 25. Now this is direct substitution in the formula since we need to find what P is. So we can say P equals to K minus E, that means 7 minus 3 divided by A, and A is 25. Is that clear? 7 minus 3 is 4, so we get 4 over 25, right? So quarter of 4 you can think. Well, if calculator is not allowed, you could also think about multiplying by 4 on both sides. So you could say this is same as 16 over 100 and then write your result as 0.16. You could do that. Well, in this question, the calculator is allowed. So we'll do 4 divided by 25 equals to decimal value 0.16, correct? Right? So that is how we're going to do it. Okay, now let's take the part B. Peter's attack value is 0.571. So this time we are given the attack value P, which is 0.571. He has 1 error, E is 1, and 7 attacks. So 7 attacks means A equals to 7. What do we need to find? So we need to find the number of kills Peter has made, the value of K, right? Kills. Now to find the value of K, we need to rearrange the formula, right? That is kind of important now. So how are you going to do it? So let's try to rearrange. So we'll first cross multiply and then add E. Perfect. So those are the steps involved. So first we'll cross multiply. Since there's less space here, I'll kind of do it on this side. So we get P times A equals to K minus E, and then the value of K will be equals to P times A plus E, correct? So that is how we are going to reorganize. Now once we have done that, we can find the value of K. So K is equal to, you have to multiply P with E, which is 0.571 times 1, and then take away the value of P times A is 7, sorry. This is 7. Then you have to take away the errors E, which is, rather add errors E, which is plus 1. Correct. So that is how you're going to do. So K is P times A. P is 0.571. A is 7. And E, which we have to add here, is plus 1. Correct? Now we can use the calculator to find this answer. So we have 0.571 times 7, and to this we are going to add 1. So in decimals, this gives you the value of 4.997, which should be written as 5, right? So number of attacks are going to be integer values. Number of attacks are not decimals, so we'll approximate always to this value, right? So we are given a rounded figure here to thousands value. Perfect. So that becomes our answer. So we get here that the number of kills will be 5 for Peter. Does make sense to you? So I'd like you to go through it once again. First part is to rearrange the formula. So we multiplied P with A, then added E to find K. Perfect. Let's move to part C. Sam's attack value is minus something. So this time we have the value of P, which is negative 0.125. He has 3 kills. We are given kills also, which is 3. And errors is 5 errors. Find the total number of attacks. So we need to find A this time. To find A, we'll actually cross multiply. Correct? So we'll cross multiply and write A as equal to K minus E divided by P. Correct? So that is better. So it will not mess up like it messed up last time. Now we need to find the value of A. We have already rearranged the formula, so we can write A equals to K, which is 3, minus errors, which is 5, divided by the value of P, which is minus 0.125. Correct? So that is what it is. So basically, both negatives will become positive. So as expected, we get a positive answer, right? Okay, let's use the calculator. So that is 1/8. So you get 16, right? Positive 16. So let's use calculator. Both minus becomes positive, and it is 2 divided by 0.125 equals to 16. Do you see that? So if you can associate decimal numbers with fractions, calculations become very easy. Do you understand? So I hope you understand and appreciate it. Okay, anyway, since calculators allowed, not much problem here. Let's move on and take question number 6. Question number 6 is, at a constant speed, distance d an object travels when it moves at a constant speed depends on how long it travels, t, and its speed s. The formula d equals to st relates distance, speed, and time. Jacob runs at a speed of 5 meters per second. So speed is given to us as 5 meters per second. How far can Jacob run in 3 minutes? So in time, 3 is in minutes, right? We need to find the distance he could run. Now in this particular question, you will notice that there are different units. Speed is given in 5 meters per second, time is given in minutes. So it is a good idea to write time also in seconds, right? So we could write 3 minutes as 3 times 60 seconds, right? That is 180 seconds. Once you have done that, then use the given formula and find your answer. So now we say distance d is equals to s times t, which is 5 times 180. Correct? So now we get our result. 5 times 8 is 40, 0, 4, and 5 times 1 is 5, and 4 is 9, and the units are in meters. Does make sense to you? So that is how you are going to solve this particular question. Okay? Part B. David runs at a speed of 3.5 meters per second. So again, we are given speed in meters per second, 3.5 meters per second. How long does it take him to run 1500 meters? So we have to this time find time, and we are given the distance d as 1500 meters, correct? So you need to rearrange this particular formula. So to find time, we have to divide by s. So when you rearrange, you get time equals to distance over speed. So in our case, distance is 1500 meters, right, divided by the speed, which is 3.5 meters per second. So if you also consider the units, which is a good idea, you can see that now time will be in seconds, right? So let's get this time in seconds. We could actually convert this to minutes if required. So we have 1500 divided by 3.5. So that gives you in decimals 428 point something like 57 seconds. Now that is a big number. It's a good idea to divide this by 60 and get the answer in minutes. So we get 7.1 minute, right? So we could write this as equal to 7.1 minute. Perfect. So it's a good idea to divide and then write down your answer. So I hope that makes sense. Part C. Anna is involved in walkathon. Her goal is to walk 25 kilometers, so she needs to cover a distance of 25 kilometers. She begins at 9 a.m. and walks at a steady rate of 5 kilometers per hour. So the speed is 5 kilometers per hour. How many kilometers does she still left to walk at 1:15 p.m. if she is to achieve her goal? So she needs to cover this distance and she's already walked from 9 to 1:15 p.m. That means the time taken is how much? So let's figure this out. So from 9 to 12 it is 3 hours, and then fourth hour, so it is 4 hours and 15 minutes, right? Since kilometers per hour is given, we could write this time in 4.15 is quarter, correct? 4.25 hours. Does it make sense? 15 is quarter. 15, 30, 45, 60. So it's quarter, that means 0.25. So that is how you could convert, right? So let us see how much distance she covered in this given time of 4 hours and 25 minutes, right? So we'll first find which will give us how much is left also, right? So let's find the distance covered. So we'll write D1. So that is not this 25. It's something else. Let's figure out how much. So D is S into T. So we are going to multiply 5 with 4.25. Correct? And get this answer. Okay. So 4.25 times 5 is equal to, in decimals, 21.25. So she has already covered 21.25 kilometers. So what is left? 25 minus 21.25. Is that okay? So that gives you a distance in decimal here, 75. So it becomes 4. 4 minus 1 is 3. So 3.75 kilometers is left. Is that clear? So that is how you're going to solve this particular question. Now, for most of our questions, we normally use this particular triangle whenever it comes to distance, speed, and time. So in such cases, you can always see distance D right on top of the triangle related with speed and time. So distance is equal to speed into time, right? So distance equals to speed into time, and time will be distance over speed, and speed will be distance over time. So you can see from this particular triangle all the three results. So it helps you to rearrange the formula and work immediately. I hope that makes sense. Now let's take the next question, which is again based on formula. The formula to calculate the percent efficiency of an energy converter is percent efficiency equals to E output over E input times 100, where E output represents the output energy in kilojoules and E input represents the energy in kilojoules. There are two questions related to this. Part A. If an incandescent light bulb has a 3.75% efficiency with an input of 1560 kilojoules of output energy, then how much light energy does it release, right? So what we are given here is that if an incandescent light bulb has 3.75% efficiency, so we are given the efficiency here, right? So let's call this as efficiency equals to 3.75. With an input of this much kilojoules of total energy, so input is E input is 1560 of total energy, then how much light energy does it release, gives out? So we need to find what is E out is, right? So that is what we need to figure out. So from the given formula, you could cross multiply and get what E out is, right? So you multiply efficiency, let's say efficiency, with E in, and then divide by 100 to get the output. Okay, does it make sense to you? So that is how you could actually do it. So let's calculate the answer. So E out is basically equal to the efficiency given, 3.75, will multiply with the energy input, 1560, and divide by 100 to calculate the answer. So we get 3.75 times 1560, and then we are going to divide it by 100 to get the answer in decimals, which is equal to, let's write down here. So we get E out equals to 58.5 kilojoules. Perfect. So that is how you're going to find the solution. Now let's look into the second part. If an LED light bulb has 88.25% efficiency, so this time the efficiency given to us is 88.25, and releases this much kilojoules of light energy. Releases means output, right? So E out is equal to 1412 kilojoules. Then how much light energy does it require? This time we need to find the input energy, right? Okay, so to get the input, we'll actually rearrange again, cross multiply. So we get E input equals to, set this comes on that side, they switch the position, cross multiply, right? So we get E output divided by efficiency times 100. So let's calculate the input this time. So we have output of 1414 divided by efficiency of 88.25 and multiplied by 100. So we have 1414 divided by 88.25 times 100 equals to, in decimals, we have 1602.3, let us say, right? So we get 1602 kilojoules. So our input this time for that much of output is 1602 kilojoules. Perfect. So that is how we are going to solve such a question, right? Now, as you can see here, for nearly 1600 kilojoules of input, the incandescent bulb only gives an output of 58 kilojoules, but the LED gives an output of 1414 kilojoules, right? So there's a remarkable difference between the two efficiencies. So efficiency is kind of important in all our operations. I hope you understand and appreciate it. So that was an attempt which I made to provide you with some excellent examples which I have seen in previous test papers on this topic. I hope they help you to understand the topic better and give you confidence to solve such questions. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.